Right, today we're looking again at straight line graphs and on how to find the equation of a straight line graph given certain information. Very important to remember the standard form of a straight line graph, y is called mx plus c. Okay, so let's go. Again, I'm going to split the graphs so that you can see how to approach each particular situation of a particular graph. Graphs cutting one set of axes, graphs cutting through the origin, and then graphs that have shifted away from the origin, even those where a y-intercept is given and when a y-intercept is not given. So have a look carefully at the kind of questions we're going to be looking at. So let's start. Straight line graphs cutting one set of axes. These are easy. They're normally 1 mark questions in a test or an exam. And this is pretty easy, straightforward. Y is called -2. It cuts the y-axis at -2. And here's another one, cuts the x-axis at 5, so x equals to 5. Simple. Now straight line graphs cutting through the origin. Now here, you would remember when you were sketching these graphs that graphs would look like y is equal to 3x, y is equal to -2x. So actually, on the standard form, the only important thing that we really need is the gradient, because the value for c is 0. So if you can find the gradient of a graph that cuts through the origin, you are then able to write the equation with ease. There are 2 methods I'm going to show you. One, if you've got a point obviously given on the graph, and in this case we're given a point with coordinates -3 and 4, substitute the x coordinate, substitute the y coordinate, and you end up with an equation where you solve for m. Very easy. Okay? Now, you can just write your equation once you've got your m. But we do have a formula for calculating the gradients of straight line graphs. You could have also used that, but remember here that your origin is another point. You need 2 points for the formula, whilst the other point given is your second point. So you've got coordinates there at the origin 0 and 0, and here you've got coordinates -3 and 4. And there y2 minus y1, x2 minus x1, and then you get your gradient. Then you can just write your equation. Pretty easy. Okay, let's look at another example here. Again, graph cuts through the origin, a point has been given, and our y-intercept is 0, that is a value for c, and therefore we can just immediately go and substitute the point. Always be careful here. You know, your coordinates are given x, y, and that is the order in which coordinates are written in a point. Now, when you come to the standard form, y comes first, which means you need to be careful in terms of your substitution. A lot of people tend to make a mistake there of substituting the x where there's y. You can't do that. You need to make sure that your x goes where x is supposed to be and y where y is supposed to be. Solve that equation. M is equal to 4. Write your equation. Y is equal to 4x. And you're done. Here's another one. Here, in a very tricky way, we're given the rise over run over here, where we need to be able to determine our gradient. But something else that is important here, if you're going to use the rise over run, we've got a negative gradient graph. So when you do your calculations of the gradient, yes, the rise is 4 units over the run of 2 units, but it's a negative gradient graph. Always remember that. And then our m is -2. We can now write our equation, y is equal to -2x. Pretty easy, just find the gradient. Straight line graphs that have shifted away from the origin, always keep out for these ones. There's one where you'll be given the y-intercept, which makes it easy because it means we can determine the value of c easily. So here's an example. Our c is 8, is cutting the x-axis at 2. That means we can actually use our knowledge of finding the gradient to find our gradient there. So first, the gradient, take note, it's a negative gradient graph, so that will be -8 units over 2 units, and that gives us -4. Okay, and then you write your equation, y is -4x plus 8, because we can already see from the sketch the graph is cutting the y-axis at 8. Here's another one. Again, pretty easy. It's a positive gradient graph, 5 units over 10 units. Just be careful. It is about the units, the number of units that give you the rise. It's not about the -5. Always want to be careful there. It's 5 units for the rise, it's 10 units for the run. That's exactly what I'm substituting there. And then it's a positive gradient graph, simplified. Gradient is a half. Therefore, your equation, y is equal to half x minus 5. Okay, very easy. Here's another one. Again, rise of 4 units. Again, be careful. Don't put negatives where there's none. Okay, it's 4 units over 6 units. But it's a negative gradient graph. It's a decreasing function. So we'd have a negative gradient. Simplified, negative 2 over 3. And then write your equation, because we've got the y-intercept. Y is negative 2 over 3x minus 4. Okay. Here now we're still dealing with graphs that have shifted away from the origin, but notice that no y-intercept is given. And this is where now it means that we actually have to calculate. We can't guess and say, oh, maybe it's roughly around about 3. No, we have to work out and go and calculate your y-intercept. And this is where now it's important to actually use your standard form correctly. First, let's work out the gradient. We've got 2 points on the graph, so the gradient of the graph, y2 minus y1 over x2 minus x1. And here it's pretty easy. We end up with 6 over 3, which gives us 2. And it's a positive gradient graph. Always watch out there and make sure that the sign of your gradient is in relation to what you see on the sketch there. Now, go to the standard form, build your graph. I substitute what I've got already, so I substitute my gradient. But then now I need to find C, and look very carefully now, this is important. We need to pick a point from the sketch and substitute that point on the graph, and it must be a point that is on the graph. You can't just pick a point anywhere else. So I've used the point with coordinates 2 and 6, and x is 2, y is 6. I end up with a nice equation of c plus 4 is equal to 6. Therefore c is equal to 2. Write your equation. Y is equal to 2x plus 2. Very easy. So that y-intercept we did not know, the value for c is actually 2 units, or 2. Anyway, let's go to the second example. Again, no y-intercept given. Okay, let's find the gradient using our formula, and we get our gradient. And then once we've got our gradient, we can now go to the standard form, build the equation, and help us find c. So substitute what we've got, and don't think everything is going to always come nicely. So you can get fractions for gradients. And again, remember, you can just substitute everything at the same time to cut down unnecessary steps. We're using that point with negative 6 and 3, so where x is negative 6 and y is 3. If you are not good with fractions, use your calculator here and then get your value for c. And our c there is negative 51 over 7. Let's go write the equation. Y is negative 12 over 7x minus 51 over 7. And you're done. Okay, so it's very important that you always be on the lookout what you've got, what do you need. And in reality, there are 2 things that you always need in order to complete your equation. Is the m and the c, that is the gradient and the y-intercept. And if your graph is cutting only one set of x's, obviously you wouldn't be using that standard form to find the equation. But for those that are going through the origin and also shifted away from the origin, you would need your standard form to help you build the equation. Okay, I hope you've understood this, and hopefully it will assist you in finding equations of graphs.